All right, today we are going to switch gears a little bit. We have been working with polynomials, and today we're going to start working with rational expressions. Rational expressions are simply a ratio, meaning fraction, of polynomials. So we're first going to start talking about what are called domain values. So the domain values are the set of all input values allowed for your expression. And in particular, the kinds of things that we're looking for when we're talking about ratios is we're looking for things that don't make my denominator equal to 0. So sometimes the easiest question is the exact opposite, and that is, well, what does make my denominator equal to 0? And so as we take a look at this, we're actually going to be looking for that quantity and saying that we can't have that. So the denominator equal to 0 is not okay, and the reason it's not is because we cannot divide by 0. And I'd like to show you just real quick why that's a problem before we start this particular problem. So if you think about trying to say, okay, well, what is 5 divided by 0? Well, if in fact it existed, it would have to equal something, we'll call it a, and it would have to be true that if I were to multiply the a by 5, I would get back to the number, the a by 0, I wrote that down wrong. I would have to be able to get back to the number 5. And there's no number that if I multiply the number a, by 0, I get back to 5. Like, that's not a possible thing. And that's actually the reason that we can't divide by 0. You see, it works with other things, right? 6 divided by 2 is equal to 3. And the reason why is because 3 times 2 is equal to 6. I can go backwards. So that's actually why this works and why this fails. So I'm not allowed to divide by 0 because I can't go backwards, right? It's not an inverse operation ability. So when I look at this value here, what I'm really asking myself or being asked when it talks about values that it can't be is values where the denominator would equal 0. In particular, we want to know where does 12 minus 3w equal 0, or where is it not equal to 0? I don't want it to be 0. So when I work with the operation that's not equals, it's like working with the operation that says equals. It has all the same properties. I'm shifting things around, I'm dividing, I'm multiplying, I'm adding, I'm subtracting. All the things work the same way. It's just that in the end, instead of it saying w equals something, it's going to say w does not equal something. So we're going to solve this. And so we'll add 3w to both sides. So 12 does not equal 3w. And then what would I do? Divide by 3. Yep. And 12 divided by 3 is 4. So the answer to the question that I'm being asked, that is, what are the excluded values, or whatever phrasing it is, in this case that's how it is it's w equals 4. I can't have w equal to 4. If I did, look back at the original problem. If you put 4 in for w, 12 minus 3 times 4 would in fact give me a denominator of 0, right? So that's what I'm looking for. I'm looking for the places that make the denominator not equal to 0 or equal to 0, depending on the phrasing of the question. We saw this before, this recall fact. We saw it back in like the first unit when we talked about fractions. If I have c times x over c times n, I have the ability, as long as c is not 0, to cancel c out and it becomes x over n. Do y'all remember that fact? We did for reducing fractions. We simplified fractions using this fact. So thinking about this fact, we're going to do the same thing now with rational expressions where I have addition and subtraction. So in particular, on this first one right here, what I'm looking for is I'm looking for factors, right? So factors are things that are set inside of parentheses, right? Factors that are identical on top and on bottom. So looking at number 2, what's identical on top and on bottom? Yeah, the 3u plus 8. So just like the c in my recall above this, the 3u plus 8 can reduce, simplify, cancel, divide out, whatever form of the verb you want to use. That's what's happening. It's going to go away. And what I'm left with on top then is, well, I'm left with the u plus 3, and I'm left on the bottom with the u minus 5. Those do not simplify. You cannot simplify term by term. I can't cancel u's out. And I'll give you an example of why real quick. let's say, ignore the numbers 8 and 48 in front. We'll deal with those in a minute. But let's say we did this. U plus 3 over U minus 5. And undoubtedly, even as I say this right now and tell you not to do it, there's going to be 3 people on the test. There's going to be probably 2 people on the quiz, because it's sooner, who are still going to do this to me. And you're going to tell me, oh, look, I can do this, and that leaves me with 3 over negative 5. You're going to tell me this. And the fact is that that's not a true statement unless U happens to be 0. If U's 0, that's true. I mean, yeah, that'll work. But you would never tell me this if you had numbers. If you had 4 plus 3 over 4 plus 2, you would not cancel the 4s, and here's why you would not. This is 7 over 6. If you canceled the 4s, you'd get 3 over 2. Does 3 over 2 equal 7 over 6? No, it absolutely does not. So you cannot cancel out terms. You can only cancel out factors. So that's why it's appropriate for us to cancel the 3u plus 8s out, but it's not appropriate for us to cancel out, say, just the u. Now, I haven't quite finished because I still have this 8 and the 48. Do 8 and 48 have any factors they both divide by? They do. They both divide by 8. So 8 divided by 8 would be 1. What's 48 divided by 8?
8.
Close. 6. Yeah, it's 6. If 64, we'd have 8. So on top, I'm left with the 1 and the u plus 3. So just u plus 3. On the bottom, I'm left with the 6 and the u minus 5. If you really want to multiply the 6 through the u minus 5, more power to you. But it's actually better, in some ways, to leave it because you can see very clearly when it's in that form that nothing else reduces. So we're going to leave it just like that. Now, problem number 3 is less friendly than problem number 2. Why?
You gotta factor out.
You're right, Isaiah. Thank you. You're going to have to factor. Number 2 is in factored form. That was very friendly. Number 3 is not. Number 3 is doing the same thing you've been doing for the past maybe 3 or 4 sections of material in your homework on polynomials, where we're factoring things. So we're going to have to factor this out. They are just binomials, which means the only factoring that can happen is common terms. So 15u squared and negative 10u, what do they have in common? 5 and u. So if I take out 5u from 15u squared, what am I left with?
3u.
3u.
Minus 2.
And then minus 2 for the 10u part. Okay, now I don't necessarily have to take out 5u on bottom, although on this one that's what comes out. But I'm simply looking in the denominator for what comes out of both terms. This time it does happen to be the same 5u that I just had. That's often not the case, right? I might have something different that's actually able to be factored out. But for this one, it is in fact 5u. So if I take 5u squared and I take out 5u, I'm left with u. And then what was it, Jenna?
Minus 5.
U minus 5, exactly. At this point, this that I've got written here is in the same form the previous one, number 2, started out as. I look on the top and I look on the bottom and I look for factors. So factors mean things that they completely have in common. 5 is a factor, u is a factor, 3u minus 2 is a factor. 5 is a factor, u is a factor, u minus 5 is a factor. Notice, negative 5 is not a factor. Negative 2 is not a factor, right? They're not multiplied by whatever's else there. They're added or subtracted, so they're not factors. But the 5 and the u both are. So my 5s would cancel. My u's would cancel because they're exactly the same as from the numerator to the denominator. And then my 3u minus 2 on top has no factors in common with the u minus 5 on bottom. So I'm done. Now if I were asked on this problem, just because we only did one of them, what value is u not allowed to equal, you would tell me 5, right? Now the reality is it's not allowed to equal 0 either, because that was originally in the denominator before I reduced it. So it's also not allowed to equal 0. But from the finished form, if that's all my problem was, u would not be equal to 5. Let's try number 4. What special form can I use to factor the numerator? Do you remember what it's called? If you don't remember what it's called, do you remember how to use it?
We just started with the negatives.
Kind of. It's not exactly square rooting, but there is sort of that sort of hidden embedded inside of it. Difference of squares is the name of the formula. So it does feel like we're kind of looking at the square root values of each of the pieces, right? So like the square root of y squared would be y. And we would do the same thing for the 16. Difference of squares that Allie mentioned is actually what it's called. They have, each piece is squared. It's something squared. Namely, this is y squared, and this is 4 squared. Both pieces are something squared. So I'm taking each of those pieces. One will be addition and one will be subtraction. And I use the square rooted kind of value, like Cameron mentioned. So I have the 4 and the negative 4 there. If you want to check to make sure or to remind yourself why this works, it's because the inner and the outer terms are the same but opposite signs. One of them's 4y, the other one's negative 4y. So those would add to 0, and they don't have a linear term in the middle. That's the difference of squares formula. We saw that last class period. On the bottom, I still have y plus 4. But what do you notice? The y plus 4s cancel, yes. There's exactly a y plus 4 on the top and on the bottom, and that's actually very friendly because what that means is that I don't even have a fraction when I'm done. I'm just left with y minus 4. So a very, very friendly one. We've got lots of factoring we're doing on this lesson. So I hope that you got that down in the last 4 lessons or whatever that we've done that have factoring, because we're going to keep utilizing it. Oh, the numerator needs to be factored, right? How will this numerator factor? Y squared, well, that's y and y. And then I have minus 24. So that negative 24 at the end tells me there's one negative and one positive. I need the numbers that multiply to 24 and add or subtract, since one's positive, one's negative, to 2. 6 and 4 will do it. So I would have positive 6 and negative 4. And the reason those are the ones that work is because the inside is negative 4y, the outside's positive 6y, that adds to 2y. That's what I wanted. My denominator, what do they have in common?
2.
A 2. So I'm going to break it apart over here just real quick. If I pull a 2 out, I'm left with y squared minus 16. Well, y squared minus 16 is still not completely reduced. It's a difference of squares, right? So y squared minus 16, I actually saw that on the previous problem, right? So that gives me y plus 4 and y minus 4. What reduces? The y minus 4s, right. So those will cancel out or simplify, divide to 1. On top, I have y plus 6. Unless I have an exactly y plus 6 in the denominator, there's nothing else I can do. And the denominator, I have a 2 and I have a y plus 4. So I'm stopped. All right, number 6 actually has multiplication of rational functions, but it doesn't really matter. It means that I could write this like this if I wanted to. If that's what that dot in between them means, I'm multiplying the tops of both, I'm multiplying the bottoms of both. I can combine them together in that fashion. Now, the first set of parentheses on the top actually has a number in common, right? What's in common? Did that show up at all? No. How about a yellow? Faded. How about that? 2x plus 18. What do 2x and 18 have in common? A 2. So I can take a 2 out of that set of parentheses and get x plus 9. How about the second set of parentheses on top? 7x plus 56. Do they have anything in common?
7.
A 7. So if I take a 7 out, I get x plus 8. Yes, indeed. Denominator. Well, there's an x plus 8. That's kind of cool because I just saw one of those. Nothing comes out of that one. How about the 8x plus 72? The 8, leaving me with x plus 9. All right, tell me something that reduces. X plus 8, gone. What else? X plus 9, gone. Anything else? The 2 and the 8, good. So we'll divide each of them by 2, leaving me with a 1 and a 4. And I think that's it. Yeah? So what remains is this 7. Whoops, I meant to highlight that. This 7 and this 1, so that's 7. And on bottom, the only thing that remains is the 4. So this one simplifies so nice that I end up with just a number that comes out of it. So there's not a prescriptive, hey, it looks too easy, hey, it looks too hard, hey, nothing came out, hey, everything disappeared completely. Those things can all happen. It just depends on the problem you're working with. So this one is 7 over 4. So the next one, again, you can draw the line and just make it multiplication and do all the pieces like we've been doing. We're going to do it piecewise. X minus 3, that's done, right? Nothing can come out of x or 3 combined. So this is still just x minus 3. However, this one is a quadratic. It's not linear, and then so it potentially would be able to factor as well. So we're going to try and factor it into 2 sets of parentheses. It is a coefficient of 1 at the beginning, so x and x. Negative 2 at the end means my signs have to be different. 1 positive, 1 negative. So I need 2 numbers that multiply to negative 2 and add to 1. Okay, so positive 2 and negative 1, right? Check to make sure. This is going to be positive 2 on the inside, negative on the outside. It should be equal to a positive x. Does it? Yes, so that is the correct factoring. All right, so then we're going to do the denominator. Now I have x squared plus 2x minus 3. Well, that's like the one I just worked with where I've got the 2 sets of parentheses. Linear, or not linear, coefficient of 1, so I have x and x. The sign at the end is negative, which means what? Different signs. So I need numbers that multiply to 3 and add to 2. 3 and 1. Which one should be positive, the 3 or the 1? Actually, the 3 should be positive because I want a positive 2 coming out of it. So on the inside, I have negative 1. On the outside, I have positive 3. That will give me a positive 2 coming out of it. My last set of parentheses, even though it is just a binomial, they do have something in common. 3x minus 9 have a 3. So I will pull the 3 out and then write that as x minus 3. Okay, is the factoring okay? If we can't get the factoring, then we can't finish the problem. Okay? What reduces? What cancels? Sorry, I was trying to get rid of all my random red marks. Okay, Zion, which one did you say? I agree. X minus 3 on top and x minus 3 on bottom. Anything else? X minus 1s go away as well. X minus 1, x minus 1. Anything else? Nope, nothing else. So on top, I'm left with x plus 2. On bottom, I'm left with, don't forget the 3 right there. There's a 3. I'm going to put it at the beginning. If you put it at the end, it's okay. I have a 3, and I have an x plus 3. Okay, any questions on that? Tell me what you remember about division of fractions. Oh, somebody started saying, what?
You would change the multiplication to 1/36.
Good. So we need to turn it into multiplication, and we make which one the reciprocal, Caden? Do you remember?
The second one.
Second one's reciprocal, you're right. So I'm going to change this. This first is going to stay the same, and I have 3x minus 9. And I'm going to make it multiplication, but I'm going to flip the second fraction upside down. Does everybody remember that fact? Stuff like this is the reason we went back and talked about fractions in the first unit, is because it's going to come back up now in fractions with actual rational values and not just numbers. So just like the previous problems I was doing, I can extend this and I can make these each factors, right, with parentheses around them to look at the pieces. 8's all alone, so I'm moving on to the 9x minus 27. What do 9x and 27 have in common? A 9. So if I pull out 9, what am I left with? X minus 3. Good. Denominator, 3x minus 9. What do they have in common? 3. If I pull out 3, what am I left with?
X minus 3.
X minus 3. Good. And then the 5 is just by itself. From the top to the bottom, what reduces? Good. X minus 3. What else?
The 3 and
The 3 and the 9. They'll both divide by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So be careful to catch everything that's not canceled on top. Don't forget about the 8. 8 times 3 is 24. And on bottom, I still have a 5 times my 1, which is 5. So once again, like I saw happen earlier, I can in fact have, and do in fact have here, just a number that comes out, 24/5. Last example. What do I do first? Flip which one, Jenna?
The last one.
The last one. Yeah, this is the one that will get flipped. So in the front, I have x squared in parentheses minus 3x plus, well, actually the parentheses aren't there just yet. I'll put them there back in a minute. Plus 2 divided by x squared plus 5x plus 6. It will become multiplication, and the fraction that comes second will get flipped. So it's 3x plus 6 over x minus 2. Is that step okay? Got to remember to flip the second fraction. Once I do that, I can extend the multiplication, or extend the division bar, the fraction bar, and I can put each numerator in parentheses, each denominator in parentheses. There's no additions or subtractions between them because that's what multiplication does. It multiplies across the top, multiplies across the bottom. Now this first one needs to factor, and it's a trinomial, 3 terms. So we'll attempt to do factoring by trial and error, which works pretty nicely because my coefficient's 1. So I have x and I have x. What will my signs be? Both negative. You're right. The sign at the end tells me that the signs have to match. The sign in the middle tells me what they have to be. Negative. So I need negatives. I need 2 numbers that multiply to 2 and add to 3. -1 and -2 in either order because the signs match. How about my next piece? I have 3x plus 6. What do they have in common? A 3, right? So we'll pull the 3 out, leaving me with x plus 2. So far, so good. I'm breaking everything down before I worry about the reducing part. Next one, x squared plus 5x plus 6. Trial and error. I have 2 parentheses with x in the front. What are my signs? Positive. I have signs of positive because everything's positive inside those. The sign at the end tells me that the signs have to match. The sign in the middle tells me they're both positive. I need 2 numbers that multiply to 6 and add to 5. 3 and 2. Multiply to 6, add to 5. And then the last one, x minus 2, does not have anything in common to pull out. What reduces?
X minus 2.
All right, x minus 2 is gone.
X plus 2.
And x plus 2 as well. So I think that's it, yeah? On the top, I have the x minus 1 and the 3. I usually write the constant first. If you don't, it doesn't matter, but 3 and x minus 1. And then the bottom, I have x plus 3. In parentheses if you want, or not. Either way is fine. Any question on that last piece of the rewriting? Okay, it's a wrap. We finished 2.6. I will see you guys on Thursday.